Hello everyone, welcome to this video. In this video, we will be solving engineering mathematics questions which were asked in GATE 2016 paper of aerospace engineering. As we can see in this slide, there were total 9 questions asked in this paper, out of which 5 questions were asked for 1 mark and 4 questions were asked for 2 marks. So let's try to solve these questions one by one. Starting with the first question, it is from the linear algebra topic for 1 mark. Consider an eigenvalue problem given by ax equal to lambda I times x. If lambda I represents the eigenvalue of non-singular matrix A, then what will be the eigenvalue of matrix A square? Okay, so as we know, we can write ax equal to lambda x. Here x is nothing but the eigenvectors corresponding to the eigenvalue lambda. Okay, then whatever operation will do on A, the same operation will reflect on lambda. So if I say the eigenvalue of A is lambda, then eigenvalues of 1 upon A, that is A inverse, okay, is 1 upon lambda. Eigenvalue of A square should be equal to lambda square, and so on. So whatever operation will perform on the square matrix A, non-singular square matrix A, the same will replicate for the eigenvalue. Hence, for this question, option B is correct, that is lambda I square. Coming towards next question. This question is again from the linear algebra topic for 1 mark. If A and B are non-singular n cross n matrices, then which of the following statement is not true? Okay, here det represents determinant of a matrix. Okay, yeah. So looking into these 4 options, we can let's say we already know some of the properties of the determinant. If A is there and if you multiply with A inverse, we'll get an identity matrix. Identity matrix means we'll have a unit, we'll have number 1 at all the diagonal elements. Okay, and if you take a determinant of it, we'll get a answer as 1. Hence the option C looks to be correct. Like we don't have to so this is true. Okay, what they're asking is which is not true. Then looking into the other options, we can see that the option D is also looks correct. That is determinant of A transpose equal to A. What is happening in A transpose? Just our elements, Aij elements are becoming Aji. Okay, for example, we take a simple matrix 1, 2, 3, 4. This is matrix A. Okay, if you take a determinant, what will happen? 4 into 1 minus 3 into 2. And if I take A transpose of it, 1, 4, 2, 3 will become 3, 2 now, but their multiplication is same. So ultimately our determinant value is not changing. Okay, it is again 4 into 6, 4 minus 6, and here also it's a 4 minus 6. So this option is also correct. If you look, the option A is also correct. Okay, this is a property of determinant. If we take a matrix A, okay, and if we take a matrix B, and if you multiply them, then it is same as taking okay, and if you take a determinant of it, then it is same as adding the determinants of matrix A and B respectively. This is the property of a determinant. But out of these all 4 options, the option B, which looks incorrect, because it's not true in this case, because determinant is not vary like this. If you take a determinant of matrix A and B, and if you add them, it will not be equal to determinant of AB. Okay, let's take a simple example I'll give you to explain. 1, 2, 3, 4 is the matrix, for example. Determinant of this matrix we know is -2. That is 4 minus 6 is -2. And similarly, 1, 2, 3, 4, again same matrix I'll take. Again here -2, but if we add them, what will happen? It is 2, 4, 6, and 8. And now if you take a determinant, 16 minus 24, which is how much? -8. Okay, so in this case, we can clearly see here, if you add them, we'll get a -4, and -4 and -8 are not equal. So this property is not true as far as determinants are concerned. Okay, hence option B is correct. If we know the properties, we can directly answer it, but this is just to explain why we have chosen option B in this case. Coming towards next question. This is again for 1 mark from calculus topic and especially from the minima and maxima. Let x be a positive real number, then function f of x equal to x square plus 1 divided by x square has its maxima at x equal to. Okay, so at what point we have maxima for this function? Sorry, minima for this function is what asked in this question. So whenever we are calculating minima and maxima, first of all, we differentiate the function and equate it to 0. So let's differentiate it. 2x, differentiation of x square is 2x, differentiation of 1 upon x square is -2 divided by x cube, and equate it to 0. So 2x is equal to 2 divided by x cube. 2 will get cancelled. X raised to the power 4 will be equal to 1. Okay, and so we can say that it's a positive real number. Okay, they have mentioned the value of x could be -1 or 1, but they are saying positive real number, hence your answer should be 1. You should not choose -1 in this case. Okay, so x is equal to 1. In this case, we have to type the answer. Coming towards next question. This question is from the vector calculus. What they are asking in this is the vector u bar is defined by y ex. Ex means we can say I minus xj. So we can write in our format, simpler format. We can say yi minus xj, where this ex and ey are the unit vectors in x and y direction. So we can convert them into I and j form. If omega bar is defined as del cross u bar, means it's a curl of a u bar. If omega is a curl of u bar, okay, we can say like this. And then they are asking us mod of omega dot del operating on u bar. Okay, so let's try to solve this question. So first step we will be doing in this case is taking curl of u bar, because we first have to calculate the omega bar. So omega bar is curl of u bar, so it is I j k dou by dou x dou by dou y dou by dou z. Coefficient of I is y, coefficient of j is -x, and coefficient of k in this case is 0. On further simplifying it, what we'll get in this is I times differentiation of 0 is 0 minus differentiation of x with respect to z is again 0. 0i plus minus j times Differentiation of 0 with respect to x, differentiation of 0 is 0. Differentiation of y with respect to z is again 0. 0j plus k times what we'll get is differentiation of x with respect to x is -1 minus differentiation of y with respect to y is -1. So it is minus 2k cap. Okay. Yeah, this is what we'll get. Now the next step would be calculating whatever they are asking. Okay, the mod of omega bar dot del operating on u bar. Yeah, so we can clearly see that we just got omega bar is equal to minus 2k cap, and we have to operate del on it. We have to take a dot product. Dot product means gradient of this vector minus 2k cap. And we can clearly say here this is the constant term, and if you take a gradient, means if you take a derivative of -2 with respect to z, it would be 0. Hence the first part of this question is 0, and if you multiply with any other vector, we'll end up with 0. Hence for this question, answer will be 0. Okay, coming towards next question. This question is from the partial differentiation. Okay, partial differential equations topic. The partial differential equation is given, which is dou u by dou t equal to alpha times dou 2u by dou x square, and where a is a positive constant, and they're asking this equation is of which type. Okay, this is again a 1 mark question. Just by looking into this question, we can clearly see that this is a one-dimensional heat equation. Okay, and whenever we have one-dimensional heat equation, we know that it is a parabolic in nature. Okay, so we can directly take option D in this case. Okay, coming towards next question. This question is again from the differential equation. This is for 2 marks. From here, the difficulty level will slightly increase. They have given one differential equation, which is homogeneous kind of differential equation. So only the complementary function will be the solution. Okay, they are asking us the value of y at x equal to 1. The simplified up form of this differential equation can be written as d square minus 4d plus 4 times y equal to 0. Okay, and now we can treat this f of d as a algebraic equation, and we can solve it to get the value of d. Once we solve, we'll get d equal to 2, 2. So the y can be written as c1 e to the power 2x plus c2x e to the power 2x, because roots are real and repeated. So this is the complementary function. Now they have given some initial conditions. First initial condition is y of 0 equal to 1. When you put x is equal to 0, the value of y is 1. So 1 equal to c1 e to the power 0 means 1 plus c2 into 0. So the next part is 0. So c1 equal to 1 is what we'll get from the first boundary condition. Okay, or the first initial condition. Another initial condition is dy by dx at x is equal to 0 is 1. So if we differentiate this, so now how y will look like? Y is equal to e to the power 2x plus c2x e to the power 2x. Y dash, which is dy by dx, is 2 e to the power 2x plus c2 times e to the power 2x plus 2x e to the power 2x. Okay, here I'm using u into v rule. If you put x is equal to 0, dy by dx equal to 1. So x is 0 means this term will go. dy by dx is 1. So 1 is equal to 2. Okay, this term will become 1 plus C2 times 1. Hence, C2 is equal to minus 1. So we got the value of C1, we got the value of C2. Now the equation we can write, which is the solution for this differential equation, is e to the power 2x minus x e to the power 2x. Okay, e to the power 2x minus x e to the power 2x. So y of 1 can be written as e to the power 2 into 1 minus 1 into e to the power 2 into 1. So it's a e square minus e square, hence it's 0. Okay, so the correct option in this case is option A. Coming towards next question. This question is from linear algebra. Here they have given us the system of linear equations and asking us what solution we'll get in this case. Before solving this question, we know that we can write this system of equations into a matrix form. So it is 2 minus 1, 1, 3 minus 2, so it's 3 minus 3, 4, 1 minus 2, 3, x, y, z equal to 1, 6, 4. So it is in the form of ax equal to b. And whenever we have this ax equal to b kind of equation, first of all, we have to check the rank of AB equal to rank of A or not. If rank of AB equal to rank of A, then these equations are consistent. If it is not the case, then they are inconsistent. If it is inconsistent, then we'll not have any solution. So it's a no solution case. And if it is consistent, we'll end up with unique solution or infinite solution. Whenever this rank of A equal to rank of AB equal to number of unknowns, and here rank of A equal to rank of AB is not equal to number of unknowns. Okay, so this chart will help us to solve this question easily. So first of all, the first step we'll be doing here is creating the augmented matrix AB. So I'll go to the next slide. 2 minus 1, 1, 3 minus 3, 4, 1 minus 2, 3. Okay, this is the matrix A. Okay, 2 minus 1, 1, 3 minus 3, 4, and 1 minus 2, 3. Yeah, and then the matrix B is vector B is 1, 6, and 4. So we have to draw a dotted line here, and we can write here 1, 6, and 4. Okay, in order to make it simpler, I would replace first row with the third row, because it will be easy to perform the operation when we have first element as 1. Okay, so let's rewrite this. 1 minus 2, 3, and then 4, 2 minus 1, 1, 1. Okay, in order to convert this into the echelon form and to find the rank of this matrix, we'll perform the operation R3 equal to R3 minus 2 times R1 and R2 equal to R2 minus 3 times R1. So by doing this, we'll be making these two numbers as 0. So what we'll get in this case? First row will remain unchanged. These two numbers will become 0, 0. Minus 3 minus 3 times minus 2, which is 6. Okay, so 6 minus 3 is 3. Then 4 minus 3 times 3, 4 times 3 times 3, correct, is 4 minus 9, which is minus 5. And here 6 minus 4 times 3, which is 12, which is minus 6. Okay, so this is what we'll get the second row. Coming towards the third row, minus 1, minus 1, minus 2 times minus 2, which is 4 minus 1, 3. Then the next number will be 1 minus 3 times minus 2. So 1 minus 3 times minus 2. So let me just check. It's 1 minus it's minus 2 times 3, which is minus 5. And the last number would be 1 minus 2 times 4, which is 1 minus 8, which means minus 7. In order to make this number 0, we'll perform the operation R3 equal to R3 minus R2. Okay, I'll just rub this part. And we will end up with 1 minus 2, 3, 4, 0, 3, minus 5, minus 6. First and second row will remain unchanged. The third row will become 0. 3 minus 3 is 0. Minus 5 minus of minus 5 is 0. And minus 7 minus 6 is again minus 1. So we can clearly see this part of the augmented matrix is A. So rank of A in this case is 2, but rank of augmented matrix is 3. Okay, so rank of A and rank of AB is not equal. And whenever it's the case, we say it as inconsistent and has no solution. Hence, option A is correct in this case. Coming towards the next question. Yeah, this question is from the calculus. They're asking us to solve a definite integral 0 to pi x sin x dx. We know a rule, if it is 0 to a, x into f of x dx. In that case, if f of pi minus x equal to f of x, or let's say f of a minus x equal to f of x, then we can write it as a by 2 times integration 0 to a f of x dx. Okay, so using this logic, we can simplify this current equation, because sine of, in this case, a is equal to pi. So sine of pi minus x means sine of 180 minus theta is sine theta. So it's a sine of x. Okay, so it satisfies the criteria. So we can rewrite this equation as pi, which is a is equal to pi in this case. So a by 2 means pi by 2, 0 to pi f of x dx. F of x is sine of x dx. Integration of sine of x is minus cos x, varying limit 0 to pi. Cos pi, if you look into the graph, cos pi is minus 1. Minus of minus 1 is 1, plus 1. minus cos of 0 is plus 1. And minus cos means it is minus 1. Okay, so minus minus plus, so we'll get a numerator will get 2, which will cancel out with the 2 in the denominator, so we'll end up with a pi. It means 3.14. So 3.14 should be the correct answer for this question. The correct range is given as in answer key. It was in between 3.14 3.13 to 3.15. So our answer is within this range, hence it's correct. Coming towards next question. This question is from the numerical methods topic, especially on the Newton-Raphson method. So they are asking us to use this Newton-Raphson method to solve the equation x e to the power x equal to 1 and begin with initial guess of x naught equal to 0.5, and the solution after one step is. Okay, so here x e to the power x minus 1 is our f of x. F dash of x in this case is equal to x e to the power x plus e to the power x. Okay, yeah, or we can write it like this also. X naught is equal to 0.5. The Newton-Raphson iteration formula is given by xn plus 1 is equal to xn. Okay, I'll just write it here. Xn minus f of xn divided by f dash of xn. And they're asking us after one step, means x1 they are asking. X1 is equal to x naught. Using this formula, we can write minus f of x naught divided by f dash of x naught. The value of x naught in this case is 0.5 minus f of x naught is 0.5 e to the power 0.5 minus 1 divided by f dash of x naught, which is e to the power 0.5 plus 0.5 times e to the power 0.5. So in this two equations, I'm just putting the values. And once we solve this, we'll end up with answer 0.517. Okay, so the correct answer in this case is the solution after one step is x equal to 0.517. For this question, the range was within 0.56 to 0.58 as per the answer key. Okay, and sorry, it's 571 in this case. Okay, 571, and our answer lies within this range. Okay, hence it's correct. Okay, once we calculate this, we'll end up with 0.571. Yeah, that's all we have from this 2016 paper. Thank you all for watching this video.